Today's seminar is on Intel MPI and the cluster edition, which Sharcnet Compute Canada has acquired a license for to run on Graham cluster, which is an addition to the existing MPI license that resides on there currently. So if you're a user of Graham presently, you wouldn't have used this yet. You would have been using the OpenMPI version of MPI to run distributed jobs, most likely. In the package with the license we acquired, there are several components. And as you can see by the list, there are some that are specific to the cluster edition, shown at the top. So items 1, 2, and 3. The others below, you'll notice there's some marked Professional Edition. So those packages appear with what's called the Professional Edition. And as you go to the Cluster Edition, you add the Cluster Edition packages. The ones below, 7 through 14, are currently available in the standard CVMFS stack on Graham right now. So this seminar, the topic of this is to introduce these new packages that are available in the Cluster Edition with a focus primarily on number 1, which is the MPI library, and exactly what that gives us. The other items in the list are other topics which we covered at later times. But just so you know that they exist there, and there'll be extras that are available in the Cluster Edition. So I'll go to the next. Now, the previous slide was the 2016 version of the MPI Cluster Edition, Parallel Studio. In the 2017 version, just to be aware that there's been several version changes and how they denote the version of the packages that you're using. And that's important when you're loading modules, that you're very aware of the version that you're using and looking up the right documentation for it to use. So I'll just go back one slide again. And if you look at 2016, they're referring to the MPI Library 5.1 Update 3. And now in 2017, it is down at number 13. MPI Library 2017 Update 3. So try to keep that straight. And as before at the other slide, it shows the additional things you get when you buy the Professional Edition or you up to the Cluster Edition. You add these 6 components as before. So given there's the MPI package, there's associated with that is the ability to run different types of the library that are maybe more suitable to your needs. One must be able to select those, and we call this in the title here initialization of components. So what you're looking at is a release version. Now this is the Intel naming scheme for these different variants of the library. They call it release, which is a single-threaded optimized library. You just look at the table. There's a debug version, again, single-threaded debug library. And then there's multi-threaded, so they call it release multi-threaded _MT, and that is the default that you get when you use the library. And there's also a debug, which is multi-threaded. So you've got 4 choices to go with the MPI, the Intel MPI library. And so it comes to how does one select these, and this is done. Intel provides a package with scripts to choose, and one would specify the argument as being release or debug or release MT or debug MT to that MPI vars.script to make the choice, and that'll set all the paths to the correct libraries that you're using. near the bottom here is a similar approach for the MKL library. You may call it MKL vars.sha, and you can find this in the root tree of the installed Intel package. And there's two main choices with that one to be aware of: 4 bytes integer, or the ILP64, which gives you 8 bytes integer, and that'll be defined a little bit better in, I think, the next slide, or the one after. So there's a whole collection of these scripts to be aware of if you're going to select the different libraries within the Intel Cluster Edition. Some of these scripts you may not ever need to deal with directly if you load the whole compiler. So the top one on this page is called compiler vars script, and it would include all of the others. It would also include, of course, the ICC and the iFort. It gives you both of them in one. And looking down the page, you'll find there's your MPI vars shell script. So each one of those shell scripts takes slightly different arguments. So it's not precisely always convenient to be digging through those to look at them. There's very common ones that we use. So we use the Intel 64 architecture, so that's one that's set in our modules, so you don't have to worry about that. Also, the naming, which I just described, is translated into modules which you can load. So you don't have to run the scripts directly. You can just load the module that you want to use, and sort of just the name of the module tells you exactly what script has been run to generate the parameters which go into the module. So this is when you're on Graham and you run module avail command with the Intel cluster, you will see these. Now these are currently not considered production level. It's still testing. That means they're not visible to all users at the moment. The name Intel cluster is chosen to be distinct from what is on Graham right now, which would be the Intel module. So when you log in, your default environment is set to include, as shown at the bottom of this slide, a couple of Intel, or it has available. It shows you what's available. There's two of them available, and the one that is actually in your environment is the 2016 version. So I hope I've been clear that the Intel cluster provides all these extra components, mainly the MPI library wrappers. Now I put at the bottom there just a little definition of the LP64 and the ILP64. So the ILP64 means long, integer long. Pointer data's, the entities all occupy 8 bytes, and it differs from the conventional LP64, where only the long and pointer data entities occupy 8 bytes, while the integer entities occupy 4 bytes. So conventional means that's typically what your code is using, and that would be the default setting. So you have a choice there with these modules which one you want to use. Just be aware that LP64 is really the default that would occur in the Intel Cluster 2016 and 2017 modules, as well as the default environment core modules. And as I mentioned, we're currently testing the Intel Cluster Edition, so it's not visible. You have to export the module path to make them available for use, and then you would unload the default Intel and IMKL modules that are present in the environment when you log in, and then you would load the Intel cluster 2017, for instance, as in this page is shown. So, after all that, we're getting down to the actual programs that are run and what's available on the system. So what's new once this module is loaded? So if you look in the first box here, you can see that you've got your standard compilers, ICC, your C compiler, ICPC, C+ compiler, and iFort. I just did an ls I star, so it caught some other things too. So that's not new, because you have that with the existing Composer edition of the compiler in your default environment. So it's all about the MPI wrappers now. There's something new here. So in the second table, the second box, I've run the ls command on those, and you can see that there's MPICC appearing, MPICXX, MPI F90, and all these commands, which are part of the cluster edition, and which you don't get in the default environment for the Composer edition right now. So if I run the same command on a system, on an installation of the Composer edition, this ls MPI star, you only get the MPI run command. And there are the shell scripts for initializing the MPI environment. So that would be a runtime environment. So with Cluster Edition, you're able to, it's equivalent to what is an SDK, or it's a compiler environment. So these wrappers are what gives you the tools to build the Intel MPI binaries that you want to run, and the license on Graham allows that to happen. So there's two components. There's having the correct license, and there's also having the software that goes along with it installed and everything available. So that is really the heart of it that's in the center box there. And these commands you'd be familiar with from using MPI before, although there's a few new ones there too. So I will go to the next slide to explain what those are. So with the Intel MPI wrappers that are provided in the Cluster Edition, there's 6 of them instead of 3 of them, which you might have expected. So the top row shows the naming convention for the wrappers for the Intel that use the Intel compilers. So what that is saying is that MPI iFort is using the Intel iFort compiler. And likewise, the MPI ICC is using the Intel ICC compiler, and MPI ICPC is using Intel ICPC. So down to the second row, not to repeat everything again, but I think it's necessary, the MPI F90 is using G-Fortran, MPICC is using GNU CC, MPICXX is using GNU G++ for compiling. So you've got 6 wrappers at your available for use. And you can tell what they're doing as shown below the box, the table. If you ran, for instance, the show switch on one of the wrappers, any of the wrappers will do. So as the example shows, MPICC -show, and that would indicate to you that it's using GCC in the compiler string that's presented. Now that should maybe ring a bell, because if you're used to OpenMPI, MPICC will be using ICC, and similar for the other commands, MPI F90 and MPI CXX would be using the Intel compilers. So it's not the most convenient wording, but their naming scheme, but it does make you appreciate what they've done. Ultimately, once you've compiled your binary, you want to run your job on the cluster. And the simplest approach, or the recommended approach rather, there's different approaches, but filtering through the documentation and trying different things, you want to use the srun command. So it's integrated with slurm. It takes care of everything for you essentially. So it turns out that there's not too many things to worry about at this point. If you've made it this far, then running your job should now probably be the easier part. Just to run it without tuning. So it is recommended that environment variable be set to the libpmi.so library, and then run the srun command. And this is coming from the slurm documentation. So there's one of the nice things about the Intel compilers is that there's they provide a lot of documentation and they support it well. So these are some of the links that you might want to take note of and look at to gain more details. I just consider just what I've run through as an introduction, sort of a hands-on introduction / first look at using the Intel cluster edition on RAM. So with all that in mind, I'm going to try to run a couple of examples which will just show the things that I talked about. So no demo would be complete without Hello World. The MPI installation provides examples that you can try just to verify it's working on a basic level before you attempt to use your code. So that's what I would recommend doing, and that's what I will do here. So we'll just grab some of those examples. So this will be done for the Intel Cluster 2016.4 edition. So we've got four versions of Hello World. And as I mentioned before, if you do module avail Intel cluster, oh, so I've already got it set. I'm sorry about that. So I've already set the variable. I will set it again. Normally it wouldn't be found if you're trying to do it there. So you would want to, again, as shown in one of the slides, is set the module path to the Intel cluster installation. You would want to unload the default environment Intel compiler and the IMKL compiler so they don't conflict. Now that will improve as the integration of the cluster edition is put into the what we call the LMOD module system. Currently, it's not part of that at this moment, so we have to do just a couple of extra steps like unload and then we can load. So we've got Intel Cluster 2016.4 loaded. That includes the MPI wrappers, which I can check just to make sure. So if I checked, indeed it's found one from the cluster edition. Okay. So I can try to compile the program. I'll just, as I did that, I can run the show command. So any guesses what that would show? That's going to show the GCC compiler was used, so it's not exactly what we want. I like to use the Intel compilers. So we'd use MPI IC. So I'll go back and I'll compile it again. Yeah. Now I can try to run it. And as mentioned before, we'll use the srun command. So we've requested two nodes and eight cores, and that's what it's given, and it has run. So if we wanted to look at we could distribute it a bit better, or uniformly if we wanted to. If we had a reason to, you could specify the number of tasks per node. A switch that's been provided by other Compute Canada YouTube videos and various places in the documentation, but we can just try it here with Intel MPI to make sure everything's working. So hopefully we'll get half of them on one node and half the processes on the other node. And indeed, it did do the placement correctly. I can do another test. MPI, the Intel provides a tune switch for tuning your application, and it uses a benchmark program to do that. And it's quite extensive when you run the tuning. So I will just compile the benchmark program to show some insight into that, some direct sort of manual usage of it. This is outside of the tuning procedures that you might do, but essentially the tuning will run these benchmarks in intelligent ways and provide suggestions on how to tune your application. But we can do it manually here. So again, it's located, it comes with the Intel software, and it's available under the installation path, which I've pasted there. So I'll just copy it over to my demo directory. So this is the benchmark programs, and if I look into the new makefile, it does provide a little bit of information here. It's going to build several binaries to test different things on the system or the job that you run. And some of the binaries, they contain these names: MPI1, standard benchmarks, X for the one-sided communication benchmarks, some I/O benchmarks, NBC, collective operations, RMA. So we'll build them all right now. And I've already got the cluster edition loaded, so I don't have to go through that again. I just simply run the make command, and you will see that it uses which MPI wrapper it uses as it goes by. So this is going to take about 2 minutes tops. And then we'll look at submitting the job with a script, as opposed to directly using the srun command, essentially interactively, which we just did. Okay, so we're finished. And you can see what we've got. So this is one of them. Another one would be mpicc, and so these are the MPI cluster edition Intel MPI binaries that have been built, which is the objective of the cluster edition. And so now I'm going to run one of these. I've got a script somewhere. So just look at this here. So you can submit this test batch and give it certain directives. As before, I mean, if you've already been running on Graham, then you're probably comfortable doing this already. And it gives you ability to place your processes if you want to. So one of the recommendations I've read is for cyclic placement of processes. Now this would be subject to running the tuning software to find the best selections to use. So scrolling down on this page, your script will need to set the module path, then load the Intel cluster edition. So it does it at this point. So you can see the cursor. I'm not sure if you can. It says export module path, and then module unload Intel and then MKL again. So we've seen that a couple of times. And then I've got some options just commented out. It's just to indicate that at that point you could add some Intel tuning variables if you wanted to. And then finally, you might recall, we'll set the libmpI variable and then run the srun command. So it's fully integrated with slurm, and there's not too much to worry about. So you just submit your job, and we will see what happens. There we go. So that was a, whoops, sorry, didn't do that. So we've got the one job running now. What I wanted to do is look at the script again, just to remind myself, yeah. So we've got 16 tasks, and they're going to run 4 per node. So we're going to run it on 4 nodes. And then to see what the so there we go. Let's just writing the output. And we can just, so we learned a couple things here, is how well if you wanted to look at the numbers that are being generated by the benchmarks and interpret them, you could. Another thing is a bit of a sanity check, I guess you could say, that everything's working properly before you run your code. So this is actually going to go on for quite a while, but it is interesting to note that how it handles the benchmarking. It reruns the test 1,000 times in incremental bytes until a certain point when the messages get so large that it starts to throttle it down and run less tests. Still, it averages the results too. You can see the range, so you've got the minimum, maximum, and the average time. They're pretty close, pretty consistent, and you would want to see that. If there's large differences, that might suggest something else is going on, if it doesn't make sense for your code. The repeatability aspect of it. Okay, so that will continue on, and likewise we will continue on testing Intel MPI Cluster Edition on Graham until it's assuredly ready for public use. But you're welcome to use it now and learn about it, just as I've shown you. Everything there you need to know to get going has been provided. So if there's any questions on this, you can ask. I was going to show the Corey Fortran problems for those, but unfortunately that's not going to happen today. It'll have to be postponed to another webinar or another presentation at a later date.